In this video, we're going to take a look at how to graph systems of linear inequalities in two variables. And in my first example, we have graph the inequalities and determine if the solution set is bounded or unbounded. So the first thing we need to do is graph these inequalities. So in order to do that, we're going to simplify each equation a little bit, and I'm going to say 2x plus y is equal to 3. And here you have two choices. One, you can solve it for y and graph it using the slope and the y-intercept, or you can plug 0 in for y to find the x-intercept and 0 in for x to find the y-intercept, and plot the two intercepts and draw your line. So that's what I'm going to do. So I'm going to say 2x plus 0 is equal to 3, and that means that x is equal to 3 halves. So I know that 3 halves and 0 is a point on this line, and then I'm going to do the same thing to find my y. So now I say 2 times 0 plus y is equal to 3, so y is equal to 3. So I know 0, 3 is a point on this graph. And now we know 2 points on this line, and we can plot the line. Now, we also need to look at this inequality. It's strictly less than. So we're not going to include the line, and when you don't include a line, use the dashed line. So let's go down to our graph, and we have 3 halves, 0 we need to plot. So each line is going to represent 1 half. So here's 3 halves, 0, and then 0, 3. So we have 3 here. And now we need to do a dotted line connecting those 2 points. And now let's graph the other line. So we have x minus 2y is equal to 1. And now I set y equal to 0. And I get x is equal to 1. So 1, 0 is a point on the line. And then we plug 0 in for x, and we get y is equal to negative 1 half. So we know 0, negative 1 half is a point on this graph. So let's plot these 2 points. So we have 1, 0, and 0, negative 1 half. And when we look at our inequality, we have greater than or equal to. So that means that we're going to use a solid line. Now that we have both equations graphed, now we need to know which way to shade it. So we're going to use a test point. So our test point is always going to be a point that's not on either line, and we always want to use the easiest point possible. So if we look at this, 0, 0 isn't on either of the lines, so I'm going to use 0, 0. And then we're going to test to see if we plug 0, 0 in, does it make the equation true? So 2 times 0 plus 0 is less than 3. And we see that 0 is less than 3, so it's true. And if the equation is true, we're going to shade towards our test point. So here we have our dashed line, and we're shading this way, which means all of the points that I just shaded are all included in the making the first equation true. And now if we test our second equation, we have 0 minus 2 times 0 is greater than or equal to 1. And we see that 0 is not greater than or equal to 1. So this is false. And if it's false, we shade away from our test point. So when we go back to our graph and we go to our line, we're going to shade away from our test point. And now the region that satisfies both of these inequalities is the region that is shaded by both. So this whole region here is our solution region. And we can see that this region is unbounded because there's no line holding it from going down in a y value forever and in this area. So we can see that we can go off in this direction forever. So that's what tells us it's unbounded. In the next example, we have 3x plus 3y is less than or equal to 9. 2x plus y is less than or equal to 4. And x is greater than or equal to 0. And y is greater than or equal to 0. First thing I want to do is graph these equations. So I'm going to set up 3x plus 3y equal to 9 and find my two intercepts. So I have, if I put 0 in for y, I get 3x is equal to 9 and x is equal to 3. And if I put 0 in for x, I get 3y is equal to 9 and y is equal to 3. So I know that 0, 3 is a point on this line and 3, 0 is a point on this line. So there's 3, 0 and 0, 3. And let's double check our inequality, and it's less than or equal to. So we're going to draw a solid line. And now we're going to graph the other inequality. So we have 2x plus y is equal to 4. And when I set y equal to 0, I get 2x is equal to 4 and x is equal to 2. So 2, 0 is a point on our line. And when I set x equal to 0, I get y is equal to 4. So 0, 4 is a point on our line. So now let's graph this line. So we have 2, 0 and 0, 4. And let's draw a line. Now that we have both inequalities drawn that weren't an axis, because remember we have x is greater than 0 and y is greater than 0, so that is going to be our x and our y axis. So now we need to do test point, and we can use 0, 0 for the inequalities because it doesn't touch either of the two lines we have drawn. We wouldn't be able to use it for x is greater than 0 and y is greater than 0, but I don't think we're going to need to use test points for them anyway. So here we go up and we say 3 times 0 plus 3 times 0 is less than or equal to 9. And we can see that 0 is less than or equal to 9. So we are going to shade everything towards the test point. And in the second inequality, we have 2 times 0 plus 0 is less than or equal to 4. And 0 is less than or equal to 4. So again, we're shading towards our test point. And now we need to remember that because x is greater than 0 and y is greater than 0, we're locked into the first quadrant. So I have highlighted the solution region, and we can see that it's completely enclosed. So we're going to say that this solution set is bounded. And that's how we graph systems of linear inequalities in two variables, and we find if it's bounded or unbounded.